All right, today's lesson is 2A. Our learning intentions for today are the student will be able to solve absolute value and inequalities. So the vocab that we should know by the end of this is what a disjunction, a conjunction, the word and or and compound and isolate, what those means in terms of the math and the absolute value problems. So a disjunction is a compound statement, and a compound statement simply means it's two or more expressions put together that uses the word or to combine those. So an or would be, you tell your parents you're going to clean your room or you're going to do your homework. That's a true statement as long as you do one of them. So an or is kind of, it's true if either one works. Whereas a conjunction is a compound statement that uses the word and. So if you use the same thing and you use the word and, I'm going to clean my room and I'm going to do my homework, then it's only true if you do them both. So an and statement, when you bring them together, means it's only the things that work for both of the statements in the compound statement. We've talked about absolute value. Again, absolute value is the distance from zero. Went over that in the last section. But we're going to be working with absolute value problems. And this is where we come into the and the or. So if we have an expression that says if the absolute value of x is equal to a, then we're going to have two statements. Either x is equal to a or x equals a negative a. If I put this in simple terms, if I take the absolute value of x and I tell you that's equal to 3, then x equals 3 makes that a true statement. Or x equals a negative 3 will also make that a true statement. So anytime we have an equal sign, we're going to use the or and write two equations. If it's a less than sign, if the absolute value of x is less than a, then we're going to again write two expressions. X is less than a, so you just drop the absolute value and write the expression. And x is greater than a negative a. So on the second equation, again, you drop the absolute value and then you change what's outside it to the opposite of what it was. So another simplified expression of this would be, if I told you the absolute value of x was less than 3, well, the numbers that make that true are anything below 3 until you get to negative 3. And anything below negative 3 will not make that true. So in this case, again, we have x is less than 3. So whether that's 2.9, 2, 1, negative 1.9. And then we go to when x is greater than negative 3. Because negative 4 would not make that true. So again, you have to write two expressions with the word and. The first expression is exactly the same without the absolute value. And on the second one, you drop the absolute value signs. You have to flip the inequality and take the opposite of what's out there. So that's when it's less than. Another way we can write this, you've probably seen this before. You can write it as a combined expression. X is less than 3 and x is greater than negative 3. So this is like x is between. That's another way to write this expression. So you can write it this way, or you can convert it to that form. Either one is acceptable. So you might see either one in the book. The last one is if it's greater than a. If the absolute value of x is greater than a, then again we have two expressions. One, exactly like it is, x is greater than a. Or again, drop the absolute value. Again, we flip the inequality sign and we take the opposite. So this would be if the absolute value of x is greater than 3, then the numbers that work for that are anything greater than 3 or anything less than negative 3. Like negative 4, the absolute value of negative 4 would be greater than 3. So with equal signs and greater than signs, they're or expressions. Anytime, the one you have to remember, if it's less than, it's an and statement. So we're going to go through how to solve absolute value equations, and you have 3 steps to do that. Now I've left space in here because I'm going to do examples, so we do it right with each step. You wouldn't need to, when you write the notes, have a bunch of space there. It's just so we can go through problems and you can see how we use the steps to solve each problem. So the first one we're going to do, 8 absolute value of 3x minus 10 minus 12 is equal to 20. So our first step to solving absolute value equations, or if we have inequalities less than or greater than signs, is isolate the absolute value. So isolate means get it by itself. So in this case, we would have to move the 8 and the negative 12 to the other side to get the absolute value by itself. Now technically you could divide by 8 first, but then you have a bunch of fractions to work with. So I'm going to go ahead and add 12 to both sides to get rid of the minus 12. And so that gives us 8 times 3x minus 10 equals 32. Now I'm going to get rid of the 8 by dividing by 8, because it's multiplied. And so we end up getting the absolute value of 3x minus 10 equals 4. So we have completed the first step once we get the absolute value by itself. Okay? We still have things inside, but we got rid of everything on the outside. So now we go to the second step. And the second step is to write the absolute value as a compound expression. So this is where we have to have 2 equations that we have to write out. So the first one, remember, since it's an equal, this tells me it's an or statement. So we're going to write the first equation just like it is without the absolute value, or rewrite it again, equals, and then the opposite of that, negative 4. So that takes care of step 2. We've rewritten our compound expression. And lastly, we just simply solve both equations, or inequalities if it's that. So on this one, we would add 10 and get 3x equals 14. Or, and then we divide by 3, divide by 3, x is equal to 14 thirds. And then we do this equation, add 10. So we get 3x equals 6. And then we divide by 3, and we get x equals 2. Now, on some of these, so you know, they're going to ask you to graph your solutions. Well, when we go to graph these, all you have to do is draw a number line. Now, you do not have to fill in 0, 1, 2, 3 and negative numbers. All you need to do when you graph these for me is draw your absolute value, your equation line. We get our number line down, and then just put the 2 numbers on in the correct order. So 2 is less than 14 thirds. You don't need to change 14 thirds to a mixed number. You can if you want to 4 and 2 thirds, but you can just leave it that way. And then since they're equal, all you do is put points on both of those lines. So that would be the work that you would show for the first problem here, and the graph that would give you the answer. And remember, this is a or statement, which means it's one of those 2. All right? Next one. Now, this one seems a little more complicated, but really, if you look at this, isolate the absolute value of each expression, we don't have any absolute value on this one. So we're done with step 1. Step 2 says rewrite the absolute value as a compound expression. Well, the only thing is sometimes in the book, they're just going to give you 2 compound expressions. And so now we just solve this. So we're all ready to step 3. So we just solve this one. Now again, you could distribute the 4. I'm just going to go ahead and divide by 4 to start with. Over here, 4's cancel. And so we get 3 minus 2x is less than -5. Then I'm going to get rid of the 3 by subtracting 3. So we get -2x is less than -8. And then we're going to divide by -2. And so we get x. Now, you have to remember, when you have a negative, if you divide or multiply both sides by a negative, you have to flip the inequality. So that would be x is greater than 4. The reason for that, if you think about it, you know 2 is less than 3. But if I multiply both sides by a -1, or divide by a -1, I get -2 and -3. And -2 is greater than that. So anytime you multiply by a negative, you'll need to flip that inequality sign. And that's because the number line's switching. All the positive numbers are going to negative. All the negative numbers are going to positive. So now we have to solve this other equation. So we're going to add 4. And we get 3/2 x is less than 9. Now to get rid of the 3/2, since it's multiplied, you divide, but remember with fractions, we multiply by the reciprocal, 2/3. And so the 2's and 3's cancel. And we get x is less than, 3 goes into 3 once, 3 goes into 9 3 times, 3 times 2 is 6. So we get x is less than 6. And this is an and statement. And x is less than 6. So you could leave it this way, or again, you could write it with x being between 6 and 4. And if we graph this, again, we just place the 2 numbers, 4 and 6. And then you have to remember, these are less than and greater than signs. So that means it can't be equal to 4 or 6. So I would put open circles on those, and it's between those, so that would be my graph, between 4 and 6. If this would have been less than or equal to for both those signs, then the difference would be I would have to shade these in. But since it was just less than for both, we would just have open circles for both of those. So ignore the green, that would just be if it was could be equal to. So one last problem I want to go through. And again, these are the 3 examples that should go on your sheet of paper that you're going to turn in with the assignment. So the last one is the absolute value of 5 minus 6x minus 10 is less than or equal to 8. So again, we get the absolute value by itself. Add 10. So we get 5x, 5 minus 6x is less than or equal to 18. Now, we've isolated, that's step 1. Step 2 is we write our 2 equations. Since it's less than, that's an and. So 5 minus 6x is less than or equal to 18. And 5 minus 6x is greater than or equal to, and then change the sign, -18. So we solve this. Subtract 5. -6x is less than or equal to 13. Divide by -6. And so we get x is less than or equal to negative. Flip that sign around because it's negative. Greater than or equal to -13/6. If we do the other one, Subtract 5. Now we get negative 6x is greater than or equal to negative 23. So now we divide by negative 6. So we get x. Again, we flip the sign around. Less than or equal to. That would be 2 negatives is a positive. 23/6. And that would be an and statement. So again, we could leave it this way, or we could write it x is between less than or equal to 23/6 and greater than or equal to negative 13/6. To graph that, again, all we need is the two numbers. So negative 13/6 and 23/6. Now, because these are less than or equal to, close circles, and again, x is between those, so that would be my graph. So that's what you're going to be doing on the assignment. I think you'll find it if you follow those steps. Hopefully you won't have any difficulty with it. Your assignment, page 154, numbers 15 to 41, the odds.